We want to find the greatest common factor of 30 and 45 using prime factorization trees. First, we'll make the tree for 30. So 30 can be written as 6 times 5. 5 is prime, so we can leave it as it is in the tree. 6 is not prime, so we have to break it down to its prime factors. 6 can be written as 2 times 3. 2, 3, and 5 are all prime factors, so the factor tree for 30 is completed. Now we'll do the factor tree for 45. 45 can be written as 9 times 5. 5 is prime, so we don't have to go any further with 5. And 9 can be broken down to its prime factors of 3 times 3. I've now rewritten 30 as its prime factors of 2 times 3 times 5. I've rewritten 45 as its prime factors of 3 times 3 times 5. Now we want to make the couples. So we have a pair of 3s and we have a pair of 5s. Remember, the greatest common factor only invites the couples to the party. So we have a couple of 3s and we have a couple of 5s. So to find the greatest common factor, we multiply 3 times 5. That means that our greatest common factor of 30 and 45 is equal to 15.